has to do with only this one. Presentations, visualizations, just like the type we described just now, where you gather your data, you do your presentation, and then draw insight from that. That's analysis, definitely. That's analysis, but there are times, sometimes you can also do analysis that is a little bit beyond that. For example, you can do something like regression analysis, for example. Okay, regression analysis can be done. You can use that for forecasting and all that. I think we have already done regression in this class and all that. So, as an analyst, you should be able to do this. But in particular, I mean, you should be able to look at data and know what to do with the data. Just know what to do. Okay, that's why I was questioning you on this data. Now looking at this data, you should know exactly what you can do with it. Okay. So, and we got it right. There are some other data you have that pie chart or bar chart would not work. Okay. So that is that. All right. So let's move on. Let's move on and see if we can handle this today. All right. Statistical sampling. Statistical sampling. Statistical sampling. Okay. In other words, what is sample? Sampling has to do with collecting of samples, ways and methods of collecting samples. So let's look at some terminology. What is population? In statistics, a population is a set of similar items or events which is of interest for some investigation or experiment. A common aim of statistical analysis is to produce information about a chosen population. So population is like the universal set of all the data that is of interest, maybe in a particular investigation or analysis. Okay. Let's say, for example, you want to do an investigation about GSS 3 students in Nigeria. So all the GSS 3 students in Nigeria will constitute the population. Okay. But usually it's not feasible to collect information from all of them. Then we have to resort to a sample, to sampling. Statistical sampling. A sample refers to a small, manageable version of a larger group, which is the population. It is a subset containing the characteristics of a larger population. Samples are used in statistical testing when population sizes are too large for the test to include all possible members or observations. A sample should represent the population as a whole and not reflect any bias. So, we've been talking about samples, but you see, there are ways of collecting samples. You don't just collect samples anyhow, okay? Although as a data analyst, most of the time you may not be collecting samples, but you should know about it. You may work in a place where they may decide to involve you in the direct collection of samples. Okay. Yeah, that's not it's not impossible. But generally, as a data analyst, the data is given to you to analyze. You are not the one that collect the data. Okay, but you should know something about how data is collected. Sampling methodology. There are different ways of collecting samples. Statistical sampling may be broadly classified as probability sampling methods, also called random sampling, and the non-probability sampling methods. In data analytics, care must be taken to ensure that the sample size is collected in such that the sample data is collected in such a way and manner that ensures such samples are adequately representative of the population. This is because samples are used to investigate properties of the population from which the sample is drawn. Every sample is drawn from some population. Okay, like the example I gave of all the GSS3 students in Nigeria. If an investigation is to be done on all the GSS3 students in Nigeria, let's say we want to know how many of them have personal mobile phones, for example. How many of them have personal mobile phones? Okay. So if we are to do that, we may not be able to collect information from all the GSS students, 3 students in the country. That would be too much, right? So we have to collect from some GSS3 students and use the data collected from those students to do the analysis. But the conclusion will be conclusion regarding the population. Am I communicating?
Yes.
So I hope we are all on the same page.
Listening, sir.
Are we all on this? Are we here? Am I audible to everyone?
I'm here. I'm here. I'm listening.
Okay.
Yes, yes.
All right. Okay, so now for the sample to make sense, I mean for the experiment to work, when you do analysis with a sample, whatever conclusion you are going to arrive at will be conclusion about the entire population. Now, for this to be achieved effectively, the sample must be collected properly, must be collected in such a way that it will have the characteristics of the entire population. That's where sampling methodology comes in. That's why we talk about the different methods of sampling. So those that are collecting the data must understand how to collect samples that will produce the desired results. Okay. Probability versus non-probability sampling. By now you should know that the concept of probability is very important in analysis. Okay. Probability sampling. This method ensures that each unit in the study population has an equal chance of being selected. It's also called random sampling. Non-probability sampling. This method uses a non-random sample from the population you want to research based on some specific criteria, such as convenience. Now, most sampling is actually probability sampling. Okay. It's very rare to use non-probability sampling. In probability sampling, now we are talking about probability sampling. Probability sampling, each item, which is research unit in the population, must have an equal chance of being selected. It's also sometimes called random sampling. This method is more time consuming and more expensive than non-probability sampling methods. The benefit of probability sampling is that if done properly, it guarantees the selected samples is adequately representative of the population. So, which means the analysis done with such data will be, the result produced from the analysis will be more reliable. The probability sampling methods include simple random sampling, stratified sampling, cluster sampling, and systematic sampling. Simple sampling. Simple random sampling is used to collect a random sample from the entire population, where each unit has an equal chance of selection. To compile a list of units, to compile a list of the units in your research population, consider using a random number generator. There are several free ones available online, such as random.org, calculator.net, and so forth. Now, you can use random numbers. Okay. When we talk about simple random sampling, there are various ways that there are various ways we can do that. Okay. Let's say, for instance, you have 100 people in a conference. Let's say you have 100 people in a particular conference. You have 100 people, and you want to randomly select let's say 10 out of those people, okay, to answer some questions. How would you do that? Let's assume that they all have seat numbers, okay? So let's say you want to use Excel. I could say, let's say they have seat numbers. I can say something like runs between. Have you ever used this function? That's random numbers between 1, 100. Okay. I need, how many people did I say I need? How many people do we need?
10, 10.
10. We are going to stop at number 10. So now, do you have any repetition here? There repetition here?
No.
Let's check.
No.
How do I do that? I can just click on remove duplicates. No duplicates found. Didn't find any duplicates. Okay. All right. So now we have 10 randomly selected numbers. So we cannot call out people with seat number 35, 31, 97, 8, 4, 76. 56, 90, 22, 77. Okay, so this is a simple example of random number generation. Is it clear?
Oh, yes. Oh,
All right, so that's similar to the use of, we can also use this lucky dip thing.
what do
That's
you want to
common.
bring out about type C code?
What? What did you say? Okay, so that's some people use this lucky dip. We know about lucky dip. When you do that, that's also simple random sampling. Okay, so you can also check out these sites, random.org and so forth. Okay, so let's proceed. Stratified sampling. Stratified sampling is another type of probability sampling. Stratified sampling is used to collect a random uh, sample from within certain strata or subgroups within the population. Each subgroup is represented from each subgroup is separated from the others on the basis of a common characteristic such as gender, race, or religion. This way, you can ensure that all subgroups of a given population are adequately represented within your sample population. Okay, so that's stratified sampling. Instead of just collecting the samples at random, you can split. Sometimes there's need to split the population into groups and then collect samples from each group. That now makes sure that there's a balance, okay? There's a balance, okay? So that each group is adequately represented in the sampling. Otherwise, you might not have too many people, too many um, entities coming from a certain group to the detriment of other groups. This is stratified sampling. Another example is, let's say we are carrying out a certain research, and then you want to divide the people into on the basis of income level, the high income people, the middle income people, the low income people, and then you want to get some sample from each of those strata, okay, each of those levels, so that whatever you do will be representative. Everybody will be adequately represented. That is stratified sampling. Okay. Cluster sampling also has to do with grouping, but a little bit different. Cluster sampling is the process of dividing a target population into groups called clusters. A randomly selected subsection of these groups then forms your sample. Cluster sampling is an efficient approach when you want to study large geographically dispersed population. It usually involves existing groups that are similar to each other in some way, e.g. classes in a school. There are two types of cluster sampling: the single or one-stage cluster sampling, when you divide the entire population into clusters; multi-stage cluster sampling, when you divide a cluster further into more clusters in order to narrow down the size. Okay, what this is talking about, let's say, for example, you want to carry out an investigation in Nigeria, okay? Now, you decide to break Nigeria into the geopolitical zones. What are the geopolitical zones in Nigeria? Hope we are still there. Hope. That's cluster sampling. Okay. So I said, like in the previous example, if you break the states, Nigeria, into the C geopolitical zone, and then you, let's say, choose a state from each geopolitical zone, and then go to each of those states to collect samples from there. Of course, from within the states, you can then also use other methods there. Okay. For example, you can resort to stratified, then random, simple random sampling. Okay, so when you do use that kind of method of breaking the country into a geopolitical zone, picking a state from there, that's a typical example of cluster sampling. Because by separating into 6 geopolitical zones, you have separated them into clusters. That's 6 clusters. Okay, so within each cluster, you pick maybe 1 or 2 states and work on those. Okay, collect sample from those. Is that clear?
Yes.
Yeah. So if you do that, then you are doing cluster sampling. Okay. Cluster versus stratified. In cluster sampling, you randomly select entire groups and include all units of each group in your sample. All units of each group in your sample. Okay. However, in stratified sampling, you select some units of all groups, and include them in your sample. Okay. Both methods can ensure that your sample is representative of the target population. Then there's the systematic sampling. Systematic sampling is also used a lot. Systematic sampling draws a random sample from a target population by selecting units at regular intervals, starting from a random point. Like in the example I gave earlier, let's increase the number of participants now. Let's say you have 2,000 participants in a conference, okay? And then you want to select a number of people out from there. Let's say you want to select 50 people out to do something, or 20 people. You can say, okay, you can use a lucky dip or whatever method to randomly decide on the number to start from. Let's say decide you do some generate random numbers, and the first that comes up is seat number 50, for example. So you start from 50. Then from that 50, you can decide that, okay, I will choose people at intervals of 10. So you are going to pick somebody on the seat number 50. You pick number 60, number 70, number 80, 90, like that until you get the number you want. If you do that, that will be systematic sampling. Okay, so let me read it again. Maybe it will make more sense now after that explanation. Systematic sampling draws a random sample from a targeted population by selecting units at regular intervals starting from a random point. This method is useful in situations where the records of your target population already exists, such as record of agencies, clients, and all that. So this is usually useful when you already have a record, a organized record of participants. Let's say you want to pick students from university now, let's say Uniben, to do something. You can look at their math number and then use systematic sampling to select them at regular intervals. Okay, that is systematic sampling. So all these we have talked about now, these are all probability sampling. Okay? These are probability sampling. Non-probability sampling is not, it's rarely used. Now, non-probability sampling, we have different methods. We have convenience, haphazard, or accidental sampling. From the technology alone, you can understand. In this case, members of the population are chosen based on their relative ease of access. So how reliable do you think that would be? For example, you can sample friends, co-workers, shoppers, people who you can easily access just for the convenience of it. Okay, so convenience sampling is non-probability sampling. Consecutive sampling is another one, also known as total enumerative sampling. Is a sampling technique in which every subject meeting the criteria of inclusion is selected until the required sample size is achieved. Okay, just pick them consecutively. That's not random. Okay, that's not random. Let's say participant in the conference, like I was talking about, maybe just pick the first 50 or so, the first 20, or from a class, or wherever, just the first that meet the criteria without randomizing it. The randomness is what makes it useful and result oriented. Snowball sampling. The first respondent refers an acquaintance. No sampling. You sample somebody, you ask that person to recommend a friend, you sample that, you ask that one, just like that, something like that. The friend also refers a friend and so on. Such samples are biased because they give people with more social connection an unknown but higher chance of selection. Okay, the response rate will be high, but the integrity of the sample will be low. Okay. Then we also have the judgmental sampling or purposive sampling, where the researcher chooses a sample based on who they think would be appropriate for the study. This is used primarily when there is a limited number of people that have expertise in the area being researched, or when the interest of the researcher is on specific field or a small group. Different types of purposive sampling, also exist. Okay. So, like I said, these are not very important compared to random sampling, so it's no point. Quota sampling, this is similar to stratified random sampling, in which the researcher identifies a subset of the population of interest and then sets a target number for each category in the sample. Next, the researcher samples from the population